This video is on entity relationship diagrams, presented by Eric Burdett, Ali Cope, and Kim Llanos.
An entity relationship diagram is a graphical tool that is used by information system designers to visually model the entities of a database and their relationships. It is used to help improve the overall understanding and design of relational databases. Data modeling is the visual representation of the data structure so that the meaning of the data is clear and it's easily communicated and shared with those who need to have access and an understanding of it. As we build databases, we must determine what data must be stored, how to store it, where to store it, and how the data is related. Before writing any code for a database, taking time to design an ERD can help save time and energy by creating a clear picture of the database needs. To create an ERD, we must follow a three-step process. Step 1, determine the data requirements. This is where we decide what information we're going to need to store in our database. Step 2, group the data together to form entities. This is where we determine what information should be grouped together. And step 3, relating entities. This is where we determine how the different entities we've created relate to each other. These 3 steps are continued until all of the data is accounted for and placed in the ERD.
So here is a very simple ERD for the meal plan class for our Yum app. We know that meal plans have meals and that meals have recipes. There are many levels of ERD diagrams, and depending on what phase of the project you are in, you may want this simplified ERD that just illustrates the class relationships of the meal plan. Or you may want to illustrate the relationships between the classes, i.e., are they one-to-one, are they one-to-many, or you might want to illustrate all of the classes in a given database plus their relationships. This simplified ERD does not include ingredient. It really is the most simplified view of the meal plan model, and as I said, it doesn't really illustrate the many-to-many relationships that our Yum app requires, and it is missing ingredient. So we also know that there are other relationships with classes such as sharing and calendar, but in the interest of time and space, just the meal plan model is being illustrated here. So this is the simplified view again of the meal plan, but it illustrates the many-to-many relationships between the user and the meal plan and the recipes, so that we know users can have more than one meal plan, meal plans can have more than one meal, and meals can have more than one recipe. So next we're going to add the recipe ingredients to the ERD that illustrate those relationships. So this is the most granular view of the meal plan, and it illustrates not just the many-to-many relationships between the user and the meal plan and the recipe, but the recipe items that actually make up the recipe. Users can have more than one meal plan, meal plans can have more than one meal, meals can have more than one recipe, and recipes can have more than one recipe item. That's all of the items that are needed to make up that recipe. And we know that they can be pantry ingredients, which are user-defined like substitutions, or they can just be the ingredient items, which are the predefined by default as part of the selected recipe. Thank you.
There are many upsides to working with entity relationship diagrams. For one, it provides an interface for easily visualizing and understanding the data model. Peter Chen, who is sometimes referred to as the father of the entity relationship model, said that the entity relationship model adopts the more natural view that the real world consists of entities and relationships. It incorporates some of the important semantic information about the real world. Thus, ERDs should be inherently easy to understand because they align closely with real-world things. With that being said, it's easy for non-technical people to view an ERD and obtain a high-level understanding of the model. This attribute also makes it an effective communication tool to convey a general overview of the data structure. In addition to its simplicity, ERDs require developers to think about the various entities and relationships that will be contained within the database. Thinking through these things allows developers to discover errors and design issues early on in the development process. Another advantage of ERDs is that they are easily integrated with relational databases. Both follow the entity relationship model, and each entity on an ERD can correspond with a table in the database, and each relationship can be easily mapped to the database with foreign keys. After an ERD is created, it should be a rather trivial task to implement that model in the database. Here are the downsides to working with an entity relationship diagram. First, there is no standard for ERD notation, which means that there are a multitude of variations from Bachman, IDEF, Crowsfoot, and there is even a specific notation for ERDs within UML as well. This means that there are a number of new symbols and terms to learn as you move across different versions. This leads us to our next point. ERDs were created to model entities and the relationships between them. Beyond that, an ERD may or may not give much more information, including the various attributes, constraints, or other objects that may be found in a database. So an ERD may be a great tool to give us a general overview of the entities and the relationships among them, but not as beneficial when we need to get specific. With that being said, it is common to see various attributes, data types, and some constraints listed in ERDs. However, the diagram itself is used mostly to give us an overview rather than digging into the specifics. The last one is that it's difficult to work with unstructured data in an ERD. As we mentioned before, ERDs have such a close connection with relational databases that it is easy to diagram its structure. However, this is not necessarily the case when we start modeling unstructured data. With the need to handle massive amounts of data in the information age, more and more companies are converting to NoSQL databases, and ERDs are not as well suited to diagram how that data is stored. Although an ERD can be used to model a NoSQL database that involves unstructured data, particularly the relationships between various entities, such as one-to-many or many-to-many relationships, this is probably not the way it will actually be stored in the database. Thus, with unstructured and denormalized data, ERDs can be used to understand and visualize the data, but how it looks on the diagram will likely not correspond to how it's actually stored in the database.
When to use an ERD. It is our recommendation that entity relationship diagrams should be used anytime an application requires a relational database or data layer. Poor database designs are often the result of lack of data independence. Data independence allows modifications to the application that doesn't require the structure of the database to change. Creating an ERD helps to ensure that the created database obtains data independence. It should be used as a first step prior to any programming to ensure that all entities and relationships are represented and as independent as possible. Alternatively, ERDs can also be developed for legacy databases to increase an understanding of the existing database structures.
This has been our presentation on entity relationship diagrams. Thanks for watching.